Ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 9, Notes 5. So we're going to be talking about finding excluded values. So first of all, let's take a look at, in general, what is a rational expression. So a rational expression is an algebraic fraction whose numerator and denominator are polynomials. Okay, so polynomials, x squared plus 2x plus 3, that's a polynomial. X plus 2, that's a polynomial. So basically we're talking about having a mixture of letters and numbers added and subtracted together with some raised to exponents. Okay? So then, what is an excluded value? An excluded value is any value that makes the denominator of a rational expression 0 or is going to be excluded. So think about this. So we've learned in mathematics that you can never divide by 0. So because you can't divide by 0, we want to exclude whatever is in the denominator. That would make it 0. So let's go ahead and let's take a look at a couple of these. So taking a look at number 1. So we have 16m plus 5 divided by m minus 6. So what we don't want is the denominator to be equal to 0. So here's what we're saying. Okay, m minus 6 cannot be equal to 0. So now I'm going to solve this for m like I was solving a normal equation. So I'm going to go ahead and add 6 to both sides, and I get that m cannot equal 6. So my excluded value for number 1 is that m cannot be 6, because if m was 6, our denominator would be 0. Taking a look at number 2, now I'm saying, okay, x plus 2 cannot equal 0. So then I'm going to go ahead and solve this for x like I would a normal equation. So x cannot equal negative 2. So excluded value is that x cannot equal negative 2. So then let's take a look at number 3 and number 4. So for number 3, again, we're going to set the denominator equal to 0. So we're saying, okay, 4x cannot equal 0. So now we're going to solve this. Well, that 4 is being multiplied by the x. So to get it over to the other side, I need to divide both sides by 4. Well, 0 divided by 4 is just going to give me 0. So I get here that x cannot equal 0. Taking a look at number 4, 6x cannot equal 0. Then again, divide both sides by 6, and I get that x cannot equal 0 again. So whenever a number multiplied by our letter is set equal to 0, our letter cannot be equal to 0. Continuing to take a look at these, again, setting the denominator equal to 0. So 3x minus 6 cannot equal 0. So to start off with, I want to bring that minus 6 over to the other side. So I'm going to add 6 to both sides. So I get 3x is equal to 6. Then I want to divide both sides by 3 because that 3 is being multiplied by the x. So 6 divided by 3 is going to give me 2. So I get that x cannot equal 2. So we're saying x can be whatever it wants. It just cannot be 2. Okay? Next, let's take a look at this next one. So 2q minus 1 cannot equal 0. So first thing I'm going to do is add 1 to both sides. So 2q cannot equal 1. Divide both sides by 2, and I get q cannot be equal to 1/2 for number 6. All right, let's take a look at number 7. Now, for number 7, it's really going to be a lot of the same thing. This is going to open the system preferences up. Okay, so let's go ahead and let's take a look now at number 7. So what we have are things in factored form. So really this is going to be a lot of the same thing. It's just going to look a little different. So what I'm saying is that x minus 4 and x minus 9 cannot equal 0. So here this is set up to use the zero product property. So all I have to do now is set each of those factors to not equal 0. So x minus 4 cannot equal 0, and x minus 9 cannot equal 0. So x cannot be, so here we're going to add 4 to both sides. So x cannot be 4. That's one of our answers for number 7. And then here we're going to add 9 to both sides. And also x cannot be 9. Okay, so that's our final answer for number 7. Let's take a look at number 8. So for number 8, I'm just going to slide these down. All right, so for number 8, we're going to have x minus 18 and x plus 2 cannot equal 0. So x minus 18 cannot equal 0, as well as x plus 2 cannot equal 0. So then I'm going to go ahead and I'm going to add 18 to both sides. So I get that x cannot equal 18. That's for one of them. Then for the second one, I need to subtract 2 from both sides, and I get that x cannot equal negative 2. So then I'm going to go ahead and I'm going to circle those answers. So then let's take a look at number 9. Whoops. So then taking a look at number 9, again, we're going to set the denominator equal to 0. So we're going to do 3x minus 12 cannot, and 4x plus 12, and both of those cannot equal 0. So what we're going to do is set each of the factors to not equal 0. So let's go ahead and let's solve this. So to start off with, we're going to add 12 to both sides. So we get 3x cannot equal 12. Then I need to go ahead and I need to divide both sides by 3. And when I do that, I get that x cannot equal 4 as one of our answers. Then, for number 12, subtract 12 from both sides. So 4x cannot equal negative 12. Divide both sides by 4, and I get that x cannot equal a negative 3. So x cannot equal 4, and x cannot equal a negative 3. Again, let's take a look at number 10. It's going to be a lot of the same stuff. Come on. So for number 10, I know that 3x minus 9 and 6x plus 18 cannot equal 0. So 3x minus 9 cannot equal 0, and 6x plus 18 cannot equal 0. So now we need to go ahead and solve each of these for x. So to start off with, I'm going to add 9 to both sides, and you get 3x cannot equal 9. Then you're going to divide both sides by 3, and you get that x cannot equal 3. Then I want to subtract 18 from both sides, and I get 6x is not equal to a negative 18. Divide both sides by 6, and I get that x cannot equal a negative 3. So both of these are excluded values for number 10. Alrighty, so let's go ahead and let's take a look now at number 11 and number 12. So if you get this, go ahead and finish it up on your own. Otherwise, I'm just going to talk through the last couple here. So let's go ahead and let's take a look at 4x minus 2 and 3x minus 1 cannot equal 0. So 4x minus 2 cannot equal 0, and 3x minus 1 cannot equal 0. So to start off with here, I'm going to add 2 to both sides. So then I get 4x cannot equal 2. And then I'm going to go ahead and divide both sides by 4, and I get that x cannot equal 2 over 4. Well, 2 over 4 is the same as 1/2 because you can divide both of those by 2, or it could be 0.5. Both of those are acceptable answers. Then, taking a look at number 12, 4x plus 1, 3x minus 2 cannot equal 0. So 4x plus 1 cannot equal 0, and 3x minus 2 cannot equal 0. So for the first one, we're going to subtract 1 from both sides, and we get 4x is not equal to negative 1. Then you're going to divide both sides by 4. So you can get that x is not equal to a negative 1/4, or you could also put that as a negative 0.25 if you wanted to go ahead and divide out that fraction. Taking a look at this next one, we need to add 2 to both sides. So 3x cannot be equal to 2. So divide both sides by 3, and you get that x cannot be equal to 2/3, which is also the same as 0.67. Always remember that you need to be watching your rounding. All right, let's take a look at number 13. So this is going to be the same thing, except this time there's 3 of them. So 3x, and you could set it up this way. You just know immediately that none of these factors can be equal to 0. So if you want to skip the step of writing them all out equal to 0, you could write that each one individually cannot be equal to 0. And then you're going to solve each of those equations. Well, for the first one, I'm going to subtract 2 from both sides. So I get 3x cannot be a negative 2. Divide both sides by 3. And I get x cannot be a negative 2/3 or a negative 0.67. For the next one, add 2 to both sides, and then I get 4x cannot be 2. divide both sides by 4, and I get that x cannot be 1/2, because again, you can divide 2 over 4 by 2, which is the same as 0.5. Then here I'm going to add 1 to both sides, and I get that 5x cannot be 1. Divide both sides by 5, and I get that x cannot be 1/5. Well, 1 divided by 5 is the same as 0.2. So you can leave it as a fraction, or you can divide it out to a decimal. I don't really care. Okay, so now we're going to go ahead and take a look at number 14. So for number 14, I have 2x minus 6 is not equal to 0, 3x minus 1 is not equal to 0, and 4x minus 16 is not equal to 0. So for the first one, I'm going to add 6 to both sides, and then I get 2x is not equal to 6. Divide both sides by 2, and I get that x is not equal to 3. Then, taking a look at this next one, add 1 to both sides, and I get 3x is not equal to 1. Divide both sides by 3, and I get that x is equal to 1/3, which is the same as 0.33. Last but not least, add 16 to both sides, so I get 4x is not equal to 16. Divide them by 4, and I get that x is not equal to 4. So then each of these represent our excluded values for number 14. So that concludes your note video for today. Go ahead and show me your completed note sheet when you are done. Thanks for listening.